Hello students, welcome to IAS Academy. In this particular video, we are going to discuss about a very well known and important atmospheric phenomena, that is cyclones, which also is referred by the name of hurricane in the North Atlantic Ocean. So let us first of all try to understand that what are cyclones. Now cyclones in the simplest term can be defined as a low pressure system that exists at a center of a weather system, and it is surrounded by the high pressure regions, high pressure isobars also we can say. And as you move away from this low pressure center, you have high pressure isobars, and as we know that if a wind is to move, it always moves from a region of high pressure to the regions of low pressure. That is why in a cyclonic system at the center, since you have low pressure, winds begin to move toward the center as such. Now when the wind is moving toward the center, due to the rotation of earth, it is not able to move in a straight line. Rather what happens is the direction of winds get deflected, and this deflection is due to a force that comes into existence. It is called as Coriolis force. That means for cyclonic circulation to establish itself, there has to be presence of Coriolis force, otherwise wind will simply flow in a straight line, fill the low pressure area, fill the low pressure gap, and weather will become stable as such. Now what happens is that because wind is not able to travel in a straight line, that begins to circulate around this low pressure center in what you can call as circulatory or rotatory fashion, and it is this motion of wind that gradually becomes very intense, the velocity becomes very high, is what we call as cyclone as such. The amount of pressure drop in the center and the rate at which it increases, that means higher the difference between the outer part of cyclone and the inner part of cyclone, higher will be the velocity of the wind, and higher the velocity of the wind, we can say the wind is more stronger, and the intensity of cyclone, the magnitude of cyclone to a large extent depend on this particular factor. So that is how we can define a cyclone as. Now if you talk about cyclone, such cyclones that develop in the tropical areas. By tropical areas, we mean between the latitude of 5 degree north to 30 degree north in the northern hemisphere, and 5 degrees south to 30 degrees south in the southern hemisphere. So all cyclones that develop or are generated within this latitude are referred as tropical cyclone. Now the question that might come into your mind is why cyclones are not developing between 0 degree to 5 degree. The answer lies in the fact that we just have discussed, is that the Coriolis force is a very essential requirement for the development of cyclone, and near the equator, that is 0 to 5 degree of latitude, we can consider it as equatorial area, equatorial zone, there Coriolis force is either absent or is present in very negligible amount as such, negligible value as such. So magnitude is almost negligible, and that is why Coriolis force is absent. And because Coriolis force is absent, there cannot be rotation of wind around the low pressure. That is why cyclones do not form in the equatorial zone. So 5 degree north to 30 degree north, that is the best possible location for any tropical cyclones to develop. Now interestingly, though we are talking about that cyclones develop, tropical cyclones develop between the latitude of 5 degree north to 30 degree north and similarly in the south, it does not mean it can develop everywhere. It does not mean it can develop at all the times, and it does not mean it can develop in all the conditions as such. There are certain conditions, essential conditions, favorable conditions we can say is required for tropical cyclone to fully establish itself over a particular area. Now these conditions we can highlight as such. The first condition is that there should be a large sea surface. Tropical cyclones interestingly do not develop over land surface. So there should be mandatorily a presence of large sea surface, and not only large sea surface, the sea surface temperature, if you measure, should be above 27 degrees Celsius. If both these conditions are present, then only possibility arise for a tropical cyclone to develop. Now apart from this, there are certain other conditions as well. One already we have discussed, that for a cyclonic condition to develop, you need a circulation of wind, and this circulation of wind cannot happen in the absence of Coriolis force. So the second most important requirement is there should be sufficiently high value of Coriolis force as such. Now coming to third location, the variation in vertical wind speed, that also sometimes is referred as wind shear, should be low. Now what basically it means is that as you go up in the atmosphere, wind should not be flowing in different directions or at different speed in different height of atmosphere. The reason is because cyclonic system is a kind of vertical cylindrical system. If you have seen the photographs of cyclone, you would have seen this kind of circulation. if wind is moving at different speed or is moving in different direction, in that case it will break cyclone, fragment cyclone into multiple parts and the system will die out. That is why you should have as small variation as possible as you go up vertically in the atmosphere. After that, you should have upper divergence above the sea level. That means if you are going in the upper part of atmosphere, rather than wind converging toward a single point, wind should be diverging in all the direction. That means it should have an outward flow in the upper part of atmosphere, and similarly you should have convergence near the sea surface. In other way, we can say that near the surface, wind should be moving toward a common point in the surface area, and in the outer surface, wind should be diverging. That means there should be outflow like this. So this kind of circulation pattern also is required for these cyclones to develop. Last we have is if there is already pre-existing weak low pressure, because again if you look at the genesis of the cyclonic system sits a low pressure center largely because of high temperature, and this area if already it is developed, then there is a high chance it can then gradually the wind can gradually begin to circulate, rotate around this low pressure system, and if the wind strength becomes sufficiently high, wind speed becomes sufficiently high, it can well then convert into a tropical cyclone as such. So these are the favorable conditions that we can highlight as far as the tropical cyclone is concerned. Now let us also try to look at the mechanism by which tropical cyclones develop. Now, if you look at the first condition which we have discussed, you need to have a large sea surface for the development of tropical cyclone. So, let us suppose here we have the large sea surface, and the second condition, if you remember, I told you there should be sufficiently high temperature, favorably above 27 degrees Celsius the sea surface temperature. So, let us imagine in this particular area sea surface temperature is sufficiently high. Now, what actually will happen is because of high temperature prevailing near the surface, the wind present near the surface become warm, and as the wind becomes warm, we know that their density decreases, they become light, and as they become lighter, they start to rise in the upward direction. Now, as the wind start to rise in the upward direction, what happens is obviously the pressure in this particular region will drop, because you know that atmospheric pressure is because of force exerted by the atmospheric gases, that is the air. So, when the air start to rise up, the warm air start to rise up, the air near the surface, the volume, you can say the atmospheric gases density, you can say it decreases, and then as it start to move in the upward direction, a low pressure center develop here. Now, as we know that wind always move from high pressure to low pressure, and because of this near the surface you see convergence of wind from all the sides. Now, as the wind start to converge toward this low pressure and the warm wind is rising up here, this warm wind then further undergoes divergence near the troposphere because they cannot be pushed anymore. So, this kind of circulation start to take place in the atmosphere. Now, keep in mind that when the winds are converging toward this low pressure center, winds are also getting warmer because as we have discussed in this area, sea surface temperature is high. So, the winds not only rotate around the center because of Coriolis force, but at the same time due to getting warm or getting warmer, they start to rise up, they are showing a spiral kind of motion, we can say. That means the wind that is reaching toward this area then start to rise up, and at the same time because of Coriolis force we have discussed, wind begins to rise in the upward direction, giving us a kind of cylindrical motion in a spiral fashion as such, which we can represent like this. Now, when this circulation begins, we can say that tropical cyclone has begun to form and it has reached its mature stage as such, and gradually in this stage itself, as the warm air rises up, warm air is rising above the sea surface, that is why it carries lot of humidity, lot of moisture with itself, and as the warm air rises up, after reaching a certain height, temperature becomes 0 degrees Celsius or in that range, sometimes even we can say below 0 degrees Celsius, and due to this what happens, the atmospheric moisture the wind contains, it begins to condense, and as a result of condensation you would see formation of dense cloud in the outer part of the cylinder that we have discussed, and gradually as the cloud becomes sufficiently dense, the water droplet will precipitate out itself in the form of rainfall, and that is why in the outer part of cyclone you have heavy rainfall with a dense cloud forming around that. Also interestingly, one thing you have to keep in mind that as the water vapor undergo condensation here, due to condensation and when the vapor converts into liquid, it releases energy. this energy is further absorbed by the gases here, by the air here we can say in more simple term, which further heats up the air, that causes further rise of air in the upper atmosphere. That is why when you talk about tropical cyclone, one statement we use that the condensation or basically the water vapor, its conversion to liquid, is the heat engine that drives the entire circulation. If condensation does not take place, so tropical cyclone will not have enough energy, because winds will not have enough heat to rise further up or go very high in the atmosphere as such. So that is how we can understand the mechanism. So this is the cross sectional view. If you look at the cyclone from top, suppose if you are flying in the sky and you are looking at a cyclonic system from the top, it will look like this to you. At the center of the cyclone, which is the calmest region of cyclone, is what we call as eye. Around the eye, the cylindrical air or wind we can say that is rising up is called as eye wall. You can say it is eye wall, and around the eye wall you have dense clouds with heavy rainfall as such. So this region is what we call as rain band. That means tropical cyclone can be divided into three parts: eye in the center, eye wall around that center, and then you have dense clouds and rainfall in the rain band region. That is how we can understand the mechanism of tropical cyclone. Now, naming of tropical cyclone is also very interesting, because if you have read the news, every time a cyclone hits India, you would see that it is referred by a particular name. Now, this naming is largely done by a regional organization that is under the World Meteorological Organization, where it lists out all the countries that are situated in the Indian Ocean region, for example, if you are talking about the case of India, and then based on the name submitted by each of these countries, in the alphabetical order the countries are organized, and one by one names of each of countries is given to cyclone while moving in a column wise manner. For example, Nisarg, Gati, Nivar, Burevi, Toktai, as you can see. So cyclone number 1, 2, 3, 4 all the way up to 13, then 14, 15, 16, 17 and so on we can say. Now, tropical cyclone develop between 5 degree to 30 degree of latitude, as we have discussed, but there are certain areas where the probability of tropical cyclone formation is very high. These areas, for example, in the Indian Ocean is both North Indian Ocean, South Indian Ocean, and in this region they are referred by the name of tropical cyclone, and most of tropical cyclone in Northern Indian Ocean largely occurs between the month of April and December. Because between December to April or December to March we can say temperature is low, it cannot result into tropical cyclone formation. Then you have Northwest Pacific Ocean, where you have typhoons. Typhoons are nothing but a tropical cyclone, but typhoon is the name given to them along the coastline of Japan and China. Similarly, other region you have in the North Atlantic, and then you have the Northeast Pacific, both along the coastline of North America. Tropical cyclones are known by other name of hurricane, and these are basically taking place somewhere in the month of May to November or June to November. Similarly, along the southwestern part of Pacific nearby the coast of Australia, you also have cyclone development. So throughout the entire major oceans, Atlantic, Pacific and Indian, we see the development of tropical cyclone. The only exception is the southern part of Atlantic, because this part of Atlantic is continuously receiving water from the southern ocean, which is relatively colder, and that is why sea surface temperature here rarely rises to a point where it can give rise to the tropical cyclone. So except South Atlantic, all the other oceans, North Atlantic, North Pacific, South Pacific, North Indian, South Indian, we see development of tropical cyclone as such. Then if we talk about the stages of cyclone, as we have discussed, the cyclone begin to develop itself around a low pressure system, and how fast the low pressure is falling, how fast the pressure is falling at the center is basically determining the strength of the cyclone or the velocity of wind as such. Now, as per the World Meteorological Organization as well as National Ocean and Atmospheric Administration of United States of America, based on the wind speed prevailing in a cyclonic system, they are referred by different names. For example, if wind in a cyclonic system is less than 36 km per hour, it is referred as tropical disturbance. If the wind is between 36 to 64 km per hour, it is categorized as tropical depression. If the wind speed further increases and reaches between 64 to 119 km per hour, it can be referred as tropical storm. And the term cyclone is used only in the case where wind speed reaches above 119 km per hour. So whenever we use the term hurricane, typhoon or tropical cyclone, whenever you hear about this term, automatically it should come to your mind, it should click in your mind that the speed of the system should be generally greater than 119 kilometers per hour as such. Similarly, as far as India is concerned, Indian Meteorological Department has classified cyclones into various categories, again on the basis of sustained wind speed. We know that wind speed in a cyclone can rise for a brief duration of time and again can fall back. So, for categorization of cyclone, what IMD has done, that it has taken an average of 3 minutes. If a particular speed of wind it is able to sustain for an average duration of 3 minutes, then only cyclones can be categorized into the given categories as such. Now here we can focus on the upper 2-3 categories, which is the most important one, and the most disastrous cyclone, the most we can say the most strong cyclones, tropical cyclones that you witness is sometimes referred as super cyclonic storm. And super cyclonic storm refer to such conditions, such cyclones where wind speed is higher than or equal to 221 km per hour. For example, recently Cyclone Amphan that has struck the eastern coast of India in 2020 can be considered as a good example of super cyclonic storm, because their wind speed has reached up to a speed of 260 km per hour. Before that, we have also witnessed a super cyclone Orissa in the year 1999, which has caused a massive damage, devastation, destruction in the entire region as such. Then we have extremely severe, that is slightly lower than super cyclonic, 166 to 220, but again it can cause heavy damage, inflict heavy damage on the what you can call as the areas through which it is passing through. Now, based on the prevailing situation, Indian Meteorological Department has a job and responsibility to alert people so they can save their life, and that is why it releases alert. For example, IMD releases green alert, yellow alert, orange alert and red alert. Red alert is the one which is the most dangerous one, where immediate action has to be taken. So that is the method by which people's life can be saved, people can be evacuated safely, and they can be safely transported away from the areas where cyclone is about to make a landfall. Now, interestingly, landfall is a term we are using here to refer to that part of the coast where cyclone is striking the coastline. As we know that cyclones, tropical cyclone, I told you earlier, it develops only over the sea surface and then it moves along with the prevailing planetary winds and then it reaches the coast. So, the exact place where cyclone reaches the coast is called as place of landfall, and that is where you would see the maximum destruction being done by cyclone. In the case of India, as you know that we have sea surrounding us on both sides. In the west you have the Arabian Sea, in the east you have the Bay of Bengal. However, latitude wise if you look, both seas are almost extending at the same latitude, but if you compare Bay of Bengal and Arabian Sea, Bay of Bengal experiences 4 times higher number of cyclone as compared to Arabian Sea. This is because of 3 major reasons. First, Bay of Bengal has shallow depth. That is why heating by sunlight is more stronger and the sea surface temperature has high probability to become higher. Second, the shape of the Bay of Bengal, if you look at the photograph here, is a kind of funnel shape, and that is why wind is able to move and converge toward a common point, which again we have discussed is one of the major requirement for tropical cyclone formation. Fourth, most of the river are discharging their water from India and Southeast Asia in the Bay of Bengal. Thus, water volume is higher, and because of higher water volume, more evaporation takes place, and because of more evaporation, there is a high moisture content, and high moisture content releases condensation heat, latent heat of condensation, that is the heat engine for tropical cyclone. So, these 3 factors have resulted in the development of higher number of cyclones in Bay of Bengal as compared to Arabian Sea. Now, as I told you that in the North Atlantic Ocean and in the North Pacific Ocean, Northeast Pacific Ocean more precisely, cyclones are also referred by the name of hurricane. There is no difference between these weather phenomena as such. Depending on where they occur, they can also be called as typhoons or cyclone as such. Now, as per NASA, the scientific name for all these kind of storm is tropical cyclone. So, in the Indian Ocean, we are using the most accurate term for the tropical cyclones or such weather system as such. So, both whether they are in Arabian Sea or Bay of Bengal, the term that we use is cyclone. Now, if you remember a few minutes ago I told you that if you are flying above the tropical cyclone, you will see this kind of structure. Again to revise, at the center you see it is a zone of calm, that is I, then around that I you have the rising wind, that is the eye wall, and around the eye wall you can see the dense clouds that are rotating, and these make up the rain band region. Now interestingly, since we are talking about rotation, one other thing we have to keep in mind is that based on which hemisphere a tropical cyclone develops, rotation is dependent on that. If a tropical cyclone develops in the northern hemisphere, it rotates in the anti-clockwise direction. On the other hand, if a tropical cyclone develops in the southern hemisphere, it rotates in a clockwise direction. That again has to do with the Coriolis force as such, which we are not going to go in detail today. Now, as far as the hurricane is concerned, in US the term that is used for the tropical cyclonic system is hurricane, and US uses a scale that is well known across the world as well, called as Saffir-Simpson scale, and this scale measures the wind strength of the cyclone as such. And on that basis, hurricanes, more precisely we can say now, can be categorized into 5 categories. Category 1 are those hurricanes where wind speed is in the given range 74 to 95, and similarly as you can see, as you move upward in the category, you have, or in the higher category, wind speed is very high. So when the wind speed reaches more than 155 miles per hour, it is referred as category 5 cyclone, which causes catastrophe, which causes extensive damage. For example, in 2010, one of the most devastating weather system that struck earth, that was Hurricane Katrina in the United States of America, that was example of category 5 hurricane as such. Now interestingly, apart from the cyclones, tropical cyclones that we have talked about developing in the tropical latitude, you have a cyclone that develop in the temperate region as well, which is called as extra tropical cyclone. Extra tropical cyclone, or they are also referred as temperate cyclone. Temperate cyclone, because they develop between the latitude of 30 degree to 50 degree north, and similarly 30 degree to 50 degree south as such. Now here if you look at the formation of extratropical or temperate cyclone, the mechanism is slightly different. In the case of extratropical cyclone, first of all, they can develop both over the land surface as well as the water surface. Now in the case of extratropical cyclone, the development is because of convergence of two contrasting air masses. Generally from the north you have the cold polar air mass that is coming, and from the south you have the warm tropical air mass that is going. So when you have a convergence between the warm air mass and cold air mass, air begins to rise. Warm air is lighter, so whenever it converges with cold air, it starts to rise. Now when the warm air is very active, it results in the formation of a front like a structure that is called as warm front. So air rises at a kind of what you can call as a slow rate, or what you can call as a gradual rate. On the other hand, when the cold wind is moving at fast speed, there also warm air rises, but here rise is much more rapid, and this front is called as cold front. Again, to define in simple term, front refer to a sloping boundary along which two contrasting air masses coming from different direction converge. Now in the case of temperate cyclone, cold front and warm front itself converge, and that is why you have a circulation of wind around the temperate cyclonic system. Let us try to understand in more detail. Now in a temperate cyclone system develop, what you have is a trapped warm air in the center, and this warm air is surrounded by cold air from both sides, as we can see from here. Now as this cold air is moving, because it is denser, it is pushing the warm air rises up in the upward direction, because here the slope is more steep. As you can see from the diagram here, the warm air rises rapidly, forming a dense tall towering cloud that is called as cumulonimbus cloud. On the other hand, if you look at this particular region, because here it is a warm air that is active, that is pushing against the cold air, it rises along a gradual slope, kind of a less steeper slope, gentle slope, and here the condensation takes place at a slower rate, forming a cloud that is called as stratus cloud. So difference in the rainfall also result, because cumulonimbus cloud causes short duration heavy rainfall with thunder and lightning, while the stratus cloud, as we have discussed in the case of warm front, causes a long duration rainfall, drizzle like rainfall that generally does not associate with, or is not associated with thunder and lightning as such. So that is how we can understand the development of temperate cyclone. Now also we have to take a look at the difference or the major differences between the tropical cyclone and the temperate cyclone. Tropical cyclone, first of all, is also referred as different names. We have talked about this before. On the other hand, mid latitude cyclone is called a temperate cyclone or extratropical cyclone. Formation also we have discussed about this. The most interesting difference is in the term of movement. For example, if you talk about, this is the equator, this is the subtropical high pressure belt, this is the subpolar low pressure belt. So planetary winds moving here are basically from west to east. These are called as westerlies wind. westerlies wind, while in this region you have the northeasterly trade winds. That means between subtropical high pressure, that is around 30 degree, toward equator you have the easterly winds moving from east to west, while from subtropical high pressure belt up to 50 degree north, that is subpolar low pressure belt, you have the movement of westerlies wind. So as a temperate cyclone develop in this particular belt, in this particular region, they move according to the direction of westerlies wind, and that is why they move from west to east. That is why it is the western coast of continent which is most affected by tropical cyclone, temperate cyclone. On the other hand, in tropical cyclone, as the planetary wind is moving from east to west, any cyclonic system also moves from east to west, and that is why the continental land masses, their eastern coast is most affected by cyclone. And now you will be able to relate that if you talk about cyclone both in Bay of Bengal and Arabian Sea, it is the eastern coast of India that receives and that actually faces or suffers damage from the cyclone. The reason is because every cyclone is moving from east to west. So every cyclone that develop in the Arabian Sea region, they move largely away from India except certain circumstances where they can turn around, but mostly eastern coast of India, that is Andhra Pradesh, Odisha, West Bengal, Tamil Nadu, these coasts are largely affected by cyclone. So that is the major differences we have to understand. Now interestingly, we also have to look at the recent research carried out around hurricanes and cyclone, and one thing is very clear among the scientific community about which we have gathered a lot of evidences is that with the passage of time, hurricanes and cyclones are becoming more severe, are becoming more devastating and damage. And the one reason behind this can be understood from the simple fact that for any tropical cyclone to develop, the first and most essential condition is high sea surface temperature, and today we are encountering global warming largely due to the anthropogenic activity of release of greenhouse gases, and that is why as global warming progresses, more and more heat is trapped in the atmosphere, which is then transferred to the oceans as such. It is believed that about 80% of atmospheric heat is transferred to the ocean, so sea surface temperature has risen in the past 50-60 years, and because of high sea surface temperature, now cyclones can form more frequently also. So warmer sea surface temperature is higher the evaporation rate, so moisture content in the atmosphere is also high, and as we have discussed, the heat engine of any cyclone or hurricane is moisture. Higher the moisture, stronger is the cyclone. So basically what you can understand is that both global warming as well as higher moisture content in the atmosphere results into more severe hurricanes, more severe cyclone as such. One example we can understand is the subtropical storm Theta that developed in the northeast Atlantic Ocean. It was 29th named storm of 2020 Atlantic hurricane season, which is rare. Generally in any particular season, it would not have more than 8 to 10. If you look at 100 years old data, not have more than 8 to 10, maximum 12 cyclone. But this was the 29th cyclone of the hurricane season. So the frequency of cyclone also has increased, and at the same time intensity and damage resulting because of cyclone has also intensified as such. So this beats the record for the most named storm previously held by the 2005 hurricane season. So after a period of almost 15-16 years, we can say number of cyclone again has increased significantly. So these are some basic facts we have to understand as far as the topic of tropical cyclone, hurricane or even temperate cyclones are concerned. That is all for this particular video. If you like the video, please hit the like button, share it with fellow aspirants, and let's subscribe to our channel for more such content. Thank you very much.